So what were buffer solutions? Buffer solutions were that I told you that everything was very sensitive to pH, and you kind of have to, I mean, the reactions, they don't like a change in pH. So H+1 concentration, OH concentration is varying around. If something likes acidic, you have to give it an acidic medium. If something likes basic, you have to give it a basic medium. So reactions are very sensitive to pH, and buffer solutions resist a change in pH when a small amount of acid or alkali is added. Most of the systems that are around you, natural systems, they kind of are naturally in the form of a buffer. I gave you the example of hydrogen carbonate. I told you that what happens is that if you add H+1, it would accept that H+1 to form, sorry, acha. So if you add H+1, the H+1 would get added to HCO3 and they would get neutralized, they would be removed. If you add OH ions, the hydrogen carbonate ion would produce or release an H+1 to neutralize that, to turn it into water, and the OH ions are neutralized. So it's kind of a buffer is formed when you have a weak acid, and also its complementary conjugate base as well. The weak acid is the one that's able to produce H+1. The complementary base or conjugate base is the one that's able to accept H+1 ion. So for example, I gave you this example that if you have ethanoic acid, and you must have ethanoate ions in the solution as well. And because ethanoic acid and ethanoate ions together would act as a buffer. If you add OH ions, the ethanoic acid over here would release an H+1 and they would neutralize all the OH ions. And vice versa, if you add extra H+1 ions into the solution, then what's going to happen is that the ethanoate ions would start gaining those H+1 ions, and they would be removed from the solution as well. So these two ions together will not allow the concentration of H+1 to change or the concentration of OH ions to change, even if you start adding more of them from outside. So which is why you have these reactions that are going on. So we did study this, and we talked about, I mean, that's it. We pretty much talked about buffer solutions. Every time you need a mixture of the weak acid plus its conjugate base as well. And we talked about the expression for Ka. I told you that since whatever is present in the solution, it's following the same equation for a weak acid, except for one difference, and that was that except with one difference, that you had to add extra conjugate base. I mean, you need plenty of this ion as well as this thing. So you add an acid, weak acid, but you need to add extra ethanoate ions or these conjugate base ions as well. So extra conjugate base is always added, and that's usually added in the form of a salt. So the salt is going to produce this specific ion, and so it's a combination of two things. You add this and you add this. But since the equation is the same, it's the same acid dissociation equation. So you can have the same dissociation constant, which is K, except for one difference, and that is that when you write this expression, now you can't write it as H+1 squared because the concentration of these two ions is not the same. The concentration of H+1 and the concentration of X minus 1, they are no longer exactly the same. Okay, what you have done is you've added more of this ion, more of this conjugate base, which has been added from outside. So these two ions, they don't have the same concentration anymore. So your K expression is going to be, it's going to be the concentration of the conjugate base divided by the concentration of the acid into the concentration of H+1. So it's basically products over reactants. Is this clear to everyone? Minail, is this clear? Ethan, Mohammed?
Yes.
Clear.
Okay, so remember this, that for buffer solutions, this is what you'll be for buffer solutions, this is what you'll be using specifically for buffer solutions. That's the formula, not H+1 squared. You can't make these two ions, you can't equate them. these two things, the conjugate base and the H plus 1, are going to have inherently different concentrations. Now, most of the questions are going to be very straightforward. For example, they might, let's try and do a question. So they might give you uh, a buffer solution, and they might ask you to calculate the pH of that buffer solution. So a buffer solution is made up of two things. One is ethanoic acid that's been added, and its concentration, let's say it's 0.15 mole per decimeter cube. And at the same time, the same solution also has the salt of the weak acid. That's your conjugate base. Remember, think of the sodium ion as invisible. I mean, the sodium ions are going to dissociate. They're going to break away when you dissolve something, and so they don't really matter. It's basically, whenever you see this, read this as CH3CO minus 1 ion only. The Na plus 1 in solution, it automatically breaks away. So doesn't really matter if there is Na plus 1 or there is no Na plus 1. As anyway, so both these things are present, and they've given you the Ka value as well for ethanoic acid. So this value is specifically provided for ethanoic acid, and the value is let's try some made up value. That's 2.5 times 10 power minus 6. Now here's my buffer solution, and he's asking me for the pH of that particular solution. So since the equilibrium that would be established would be the same one, okay, so we're dealing with the same equilibrium. This has a concentration of 0.3 mole per dm cube, and this has a concentration of 0.15 mole per dm cube. So since the concentrations are given, you can write the K expression. The K expression would be the conjugate base concentration into H plus 1 concentration. We don't know what the H plus 1 concentration is, so it's 0.3 multiplied by H plus 1 concentration, we are not sure, divided by the acid concentration, products over reactants, so that's 0.15. And the K is given, that's 2.5 times 10 power minus 6. So can anyone quickly tell me what is H plus 1 in this? What value do we get?
Sir, I'm getting 1.25 into 10's power minus 6.
And what's pH then? That's the negative log of? So what do we get for
5.9.
As we're getting 5.9. So a pretty straightforward question. You'll be given the conjugate base concentration, you'll be given the concentration of the weak acid. You just plug in the values or just do products over reactants. The K is given, and you'll find the answer. ठीक है? Is this clear?
तो आपने फिर pH का क्या किया है? pH के साथ ये
क्या किया?
नहीं मतलब K वैल्यू हमारे पास I mean क्या है ये? Is it 2.5 and 10 is to our minus 6?
नहीं, that was already given.
अच्छा.
But the only thing we had to find out was the concentration of H plus 9s, which we did.
सही है, ठीक है.
Okay. So let's do another question similar to this one. Let's say I have a question. So the only trouble is, when you're given two things, you just have to identify which one is the weak acid, which one is the conjugate base. Okay, that's the only thing you have to identify, and just put in the just plug the values in the expression. So for example, in this question, they've told us that there's another buffer that's made, and that buffer is made up of two things. It's got NH4Cl. Its concentration is given as 0.45 mole per dm cube. And there's another thing which is NH3. And its concentration is given as let's say 0.3 mole per dm cube. And they've given us the Ka for NH4 plus 1. That K is 7 times 10 power minus 7, let's say. Okay, that's a K. First thing, can anyone identify out of the two things that are mixed together to form a buffer, which one is the weak acid, which one is the conjugate base out of the two? Anyone?
NH4 is the
NH4Cl.
acid
ठीक
and
है.
Yes.
NH3 is a conjugate.
ठीक है. So just remember and always think of the Cl line as invisible. ठीक है? It doesn't really matter. It's going to break off when you mix it in water. It's going to dissociate. So it's basically, this thing is basically NH4 plus 1. So NH4 plus 1 is your weak acid because it's going to dissociate to form NH3, which is going to be the conjugate base. So you have the concentration of NH4 plus 1, which is 0.45 mole per dm cube. And you have the concentration of NH3, which is 0.3 mole per dm cube. And what you can do is you can just find K. K is already known, that 7 times 10 power minus 7. So you just do products over reactants or conjugate base into H plus 1 concentration. So that's 0.3 times the concentration of H plus 1 divided by 0.45. So what do we get?
1.05 into 10 power minus 6.
And if you take the negative log of that, that would be
5.976.
5.976.
5.97 round up to 6.
So you're getting 5.976. Okay. So you found the pH. So the only trouble is just identifying which one is the weak acid, which one is the conjugate base. So I'll without any calculations, just tell me if there's a buffer, and that's made up of two things. One is Na2SO4. Its concentration is given, and you have NaHSO4. So can you tell me which one is the acid, which one is the conjugate base?
NaHSO4 is the acid.
Is the acid.
Okay, so this is the HSO4 minus 1 ion, this is the SO4 minus 2 ion. Just ignore the Na. Okay, think of it as being invisible, not there. So it's HSO4 minus 1 that's ionizing, and it's in equilibrium with SO4 minus 2. Okay, so you have to learn how to identify which one is the acid and which one is the conjugate base. Now, most questions are not going to be this straightforward. I mean, the expression would be the same. I mean, you'll be using, where's the formula? You'll be using the same formula. That's. I mean, this is the formula that you'll be using, except they're going to mix it up with. Sometimes, a lot of times, they actually mix it up with a moles question. What that is that they won't just directly give you the conjugate base concentration or the acid concentration. You would have to actually go in, calculate their concentrations. So a lot of times you get questions which are kind of like they're kind of like a moles question, but at the end of the day they're asking for the pH. So let's try one of those questions. So one question could be that I've got 100 cm cube. So it's a moles question, but at the end of the day, they're asking for the pH of the buffer. So 100 cm cube of 0.15 mole per dm cube ethanoic acid is mixed with, so that is mixed with 40 cm cube of 0.1 mole per dm cube NaOH. Okay, that's what's provided. And they've given us the Ka value for ethanoic acid. Just 1 second. So they've given us the Ka value of ethanoic acid, and that value is 1.8 times 10 per minus 6. And asking for the pH of the buffer. What's the pH of the buffer? Now the first question is it even a buffer in the first place or not? What are they doing? They're mixing ethanoic acid with NaOH. Now we have a weak acid, but this one is not the conjugate base. So apparently they should not form a buffer. Because a buffer is formed when you have a weak acid and its conjugate base. Is this point clear? So right at the beginning, they're not forming a buffer in the first place. Is this clear?
Yes, sir.
TK, Mohammed Ethan, is this clear? Zoha?
Yep.
So
Yes.
okay, so they're not forming a buffer. So why are they asking for the pH of the buffer? Because a buffer is formed when you have a weak acid and its conjugate base. So the thing is that ethanoic acid is an acid and NaOH is a strong base. What would happen is that the two are going to react with each other. I mean, so there's no buffer forming initially, but there's going to be a reaction. And in that reaction, a salt would be produced of ethanoic acid. It's going to be an acid-base reaction. The salt of a sodium ethanoate molecule compound would be formed, and a water molecule. It's an acid-base reaction. So in the beginning, there's a reaction that's going on. Can anyone tell me how many moles you've got over here of ethanoic acid? It's 100 into 0.15, so I think it's what, 0.015 moles?
Yes, 0.15.
0.015, right? I said, what about how many moles you've got over here? 0.004. Well, 40 cm cube or 0.1 mole per dm cube. So that's 40 into 0.1 divided by 1000.
Yeah, 0.04.
1 0, 2 zeros. I think they're going to be 2 zeros.
Yes.
Yeah, 20.
Okay, so it's 0.004 moles. So the first thing is, what do you have when you mix these two together? There's going to be a reaction, and at the end of the reaction, what does the mixture contain? So which one is in excess? Apparently, you added too many moles. I mean, they react in 1:1, right? So too many moles are added. So this one is in excess. And this one, your 0.04 moles, that's your 0.004 moles, that's your limiting reagent. NaOH would react completely, right? Because 0.004 would react. It will completely get used up. And how much of ethanoic acid would react out of the 0.015? It's 1:1. So 0.004 moles of this would also react. So you started off with 0.15, and 0.004 have reacted. So what are you left with? You're left with 0.00. I mean, these moles are gone. You're left with 0.011 moles, I think.
Yes.
Yes.
So they would be left at the end of the reaction. So I'm just going to repeat what we did over here. Okay, I figured out the moles of ethanoic acid that are reacting with NaOH. There's too much ethanoic acid added, so that's in excess. 0.004 moles, that's your limiting reactant, that would react completely. But the ethanoic acid would not be able to react completely. Our 0.004 would react with 0.004. So out of the 0.015, 0.004 would be gone, and you'll still be left with 0.011 moles of ethanoic acid. So that means, what that means is that at the end of the reaction, your mixture would still contain some ethanoic acid. And exactly how much? 0.011 moles. Is this clear to everyone?
Yes.
Yes.
I said, then what happens when they react? Now, NaOH is reacting. We know exactly 0.04 reacts with 0.04. So over here, how much of this salt would be produced? It's going to be 0.004.
004.
That's the amount that's going to be produced. So that means at the end of the day, your mixture would also contain a salt of the same weak acid. So what's happening is, okay, after the reaction is over, the mixture would contain two things. It's going to contain it would have the conjugate base. So that's your conjugate base. And at the same time, it's also going to have the weak acid as well. That would be left behind from after the reaction because it was added in excess. So now it's a buffer. Okay? After the reaction is over, now it has turned into a buffer because there's a weak acid plus the conjugate base as well. And now you can use the formula, which is that your mixture would contain two things. It would contain ethanoic acid, and it would also have the conjugate base as well. How many moles of this? The mixture would contain 0.004 moles of these ethanoate ions. It would contain how many moles of 0.011 moles of this thing, right? So this is your solution. This is the end story of your solution. All of this would be present in your solution, and what do you do with this? I mean, you can just add in, what was the Ka value? It was 1.8 times 10 power minus 5. So it's product concentration or the conjugate base concentration, which is 0.004, multiplied by the H+1 concentration, which is unknown, divided by the concentration of ethanoic acid, which is 0.011 moles. Now, there's one thing I did not use use concentration. It was, I mean, the expression required concentration, but I just plugged in moles. And the reason I plugged in moles is because to find concentration, you divide by volume, right? But since
Sir, why do we have 0.004 moles of this conjugate base?
reaction के अंदर ना कि how much NaOH was reacting?
I mean 0.004.
And it was reacting with 0.004 moles of ethanoic acid, right?
Yeah.
So one reacts with one to produce one. So this is the amount that would be produced of the conjugate base. Is this clear?
Yes. I mean, if there were, let's suppose, there were 2 moles of this acid, C3COOH, then फिर क्या होता? फिर would we be getting 0.008 moles of this conjugate base?
No, it's always, I mean, this is the thing that is limiting the reaction, right? Okay. I mean, moles are decided by the limiting reagent because this will not be able to react completely. Like even if you keep increasing, even if you add 100 moles of it, the amount of moles that would be able to react would just be 0.004. Okay. This gets used up.
I mean, so the point is, what I'm trying to ask is, we measure or we compare the concentration or the moles of products with the limiting reactant.
That's a basic idea. That's a basic concept of limiting in excess. That it's always because the excess moles are irrelevant because they're not going to react completely. You get my point?
Exactly. Yeah.
So if all the moles are decided by the limiting reagent, okay, it's going to react completely. Okay? So this 0.015 is completely irrelevant. Okay? 0.015 moles are never going to take part in the reaction. Adam, I told you about Na+1. I mean, Na+1 is just roaming around, it's floating around. I mean, think of it as a solution. It's just a spectator and it's not doing anything. It's just, so I just told you that think of Na+1 as not being there. Adam, is this clear? It has absolutely nothing to do with this reaction. So I mean, there's water as well. I mean, all of these things are just spectators. They're not actually taking part in the reaction themselves. So always remember, just think of whenever you see a salt, think of the metal ion as just completely irrelevant, or just don't think of it. Just think of it as something that's invisible. Okay? It's basically just ethanoate ions. And so you have this reaction and you can plug in the values, and the reason you can plug in the moles values directly is because it's numerator divided by denominator. So I mean, there's no point in dividing by volume and finding concentration, because the volume part would automatically get cancelled out when you divide them. So you can directly use moles. The moles of the conjugate base divided by the moles of the weak acid. No need to find concentration explicitly. So can you tell me what the value of pH is in this case?
I got 4.31.
Me too.
So the pH comes out to be 4.31. Let's try another similar question. Now in this question you've got the question is 50 cm cube of 0.2 mole per dm cube NH3 is mixed with what? With let's say 30 cm cube of 0.2 mole per dm cube HCl. And the K for NH4 plus 1 is given, which is some made up value, let's say 4.5 times 10 power minus 8. So this is given, and you're being asked to find the pH of the buffer. Now, the very first thing is they're not going to form a buffer. These two are not going to form a buffer. If you mix NH3 and you mix HCl, I mean, it's not a conjugate base and a weak acid mixture. What would actually happen is that the two are going to react with each other. So that's the first thing that would happen. The NH3 would start to react with the HCl, and together they would start forming NH4Cl. So how many moles of NH3 do you have over here? What is this? Is this 0.1?
0.01.
Okay, so this is 0.01 moles. And how many moles of HCl do we have?
0.006.
So we've got 0.006 moles. Now it's all 1:1, so which one is in excess? That 0.006.
NH3.
Okay, so 0.006 would react, right? So all the HCl is gone. And 0.006 would react with 0.006 of this, 1:1. So what's left? I mean, the 0.01 would be gone. Instead, out of the 0.01, 0.006 would react, so only 0.004 moles would be left at the end of the reaction. Right? Is this clear? So your mixture would have these leftover NH3 molecules. Is this clear?
Yes.
Yes.
And 0.006 would react with 0.006. On the other side, the moles of NH4Cl that would be present in the mixture would be 0.006 moles. So now it's a buffer. Why it's a buffer? Because your mixture contains two things. It contains NH4 plus 1 ions, and there is leftover NH3 as well. So both things are present in the mixture now. And they would be together, if they're present together, they would be forming an equilibrium. And the moles of NH3 are 0.00. And the moles of NH4 plus 1, this is plus 1, that's 0.006. Okay, so you've got 0.004 moles and 0.006 moles of this. So all you have to do is just use the expression for K. I think I gave you the 4.5 times 10 power minus 8. And that's equal to 0.004, which would be divided by 0.006 into the concentration of H plus 1. Is this clear?
Yes.
So you can just find pH now. What's the pH?
I'm getting 7.17.
Yes, same here.
Okay, so the pH is 7.17. TK, is this clear, everyone?
Yes, sir.
Yes, sir.
Now, another thing is you might get a different. I mean, you should know one property of this. Of these types of questions and about K. Sometimes they might ask you that equal concentrations of equal concentrations of what? Of ethanoic acid and sodium ethanoate are mixed. So equal concentrations of ethanoic acid and sodium ethanoate are mixed together, and when they're mixed, resulting pH. It's a buffer, obviously, because it's a mixture of a weak acid and conjugate base. The resulting buffer has a pH of what? Has a pH of, let's say, 5.1, and they're asking us find Ka. So we know we know that this is the weak acid. Both things are they're already provided. So you've got a weak acid, you've got a conjugate base as well. Both things are given. Just a second. Anyway, so both things are given. You have to find K. What's the expression for K? K is the conjugate base concentration, which is CH3CO minus 1 into H plus 1 concentration divided by the weak acid concentration, which is CH3 and COOH. So that's your expression. Now the only thing that's given is the pH. How would you find K, and what would happen? How would you find the concentrations of the two acids?
Are they equal? Do they cancel out?
Okay, so they're kind of equal, so they would cancel out, and K would be equal to the concentration of H plus 1, which we can find out that if the pH is 5.1, the H plus 1 concentration would be 10 to the power minus 5.1, and your K value would be exactly the same. So just remember, if equal concentration, you should note this down, equal concentrations are used, And that's how you find Ka. What you do is you add equal concentrations of ethanoic acid and the conjugate base, and you just calculate pH by a pH meter. I mean, the H% concentration would be exactly the same as the Ka value. So equal concentration of weak acid and conjugate base are used. Then at that, in this situation, Ka and H+1 concentration are going to be exactly the same. Is this point clear?
Yes, sir.
Okay, so that's experimentally that's the easiest way to calculate Ka. Just add equal concentration of the salt and the weak acid, and just measure the pH. The H% concentration would be exactly the same as the value of Ka, or you can say the pH would be the same as pKa. So that's one easy way of measuring Ka. Is this clear? This thing?
Yes, sir.
Sir.
Yes.
Yes.
So what if it's not at equal concentration?
I mean, then
If they
obviously,
don't mention it.
you can't solve it.
Uh,
I mean, you need to, or maybe they might just give you that the concentration of ethanoic acid is 2 times the concentration of the salt. So you can just write ethanoic ions are X, and this would be 2X. So the X would get cancelled out. So something like that, right? So they can do that as well. So let's continue with this next time. TK will do another question. That's an even more complicated question, which has come in your exams. Most of the questions, most of the questions would be very easy. You just plug in the values. Some of the questions would be linked with moles, and then we'll do one question which was kind of difficult. So we'll do that in the next class then. So let's continue tomorrow. Okay, everyone.
Thank you.
Allah Hafiz.
Thank you.
Take care. Allah Hafiz.